Hello, and welcome to a tutorial in render passes for Spark AR version 92. So, in this version of Spark AR, we're given the ability to bypass the default render pipeline in Spark AR Studio and produce multiple rendered results in our AR effects. And what that means is each pass is an object that we're defining that gets rendered to the canvas at the time that we define it and in the quantity that we define it. So how many of those objects we want to define and show at any given time is now up to us, which is amazing because you could create some interesting effects and some great results that work for a variety of devices with just this one feature. So let's dive into it and start to understand it. Okay, so the way to understand it is actually to look back at how we were already using render passes before. So if we look over at our device here, we see it's the top of the scene hierarchy. Now everything gets folded up if I fold up that arrow, and that means all these scene objects are children of that device. And what that means in terms of render order is that everything that gets rendered is going to be determined by its place on that hierarchy. So device comes first, that gets rendered first, then camera, then all of this, then we get our first scene object that we created, which is a canvas. And that scene object to be given a layer. So when we give scene objects different layer assignments, we're actually also telling it to render in an order that we determine by this menu here, which is the layer order. And the different layers, as they're arranged here, will determine what we see first, what comes next, and what comes after that. So if you have an object that you want to show on top of a camera texture, then you can use the layer order in combination with their scene hierarchy to create a render order that makes it so that the render order of the objects is correct, so that you see the 3D object on top of the camera texture like you're wanting it to. So that's how you use render passes already. This is how you're going to understand using them in the new context of defining each step, because you're going to think about every object that you're defining and how it would be arranged if it were in the scene hierarchy. And if you're thinking like that, then it's not that much of an adjustment to start working with it. So what we're going to do is we're just going to start out by deleting the object that I already imported, and we're going to go to the device and find render pass on the right here, and next to default pipeline it says create, and if I click create, then it creates the 4 objects that I need to make a render pass, which are here. And you can see that no signal value disappears and gets replaced with the camera texture. So the camera texture is the background. Now, if I take away the camera texture as the background, I still see what appears to be the camera texture. But what it actually is the scene object of the canvas that's being shown, because it's being defined here as the object that the scene render pass consumes. So the scene render pass can take in an object and all of its children, meaning everything in underneath the device, and then send it to the screen output. And if I wanted a particular object in my hierarchy to be rendered to the canvas, I would drag that into the scene like I did for the 3D text object, and I put that into render pass, and now only that one 3D text object is showing. Okay, let's do that again. If I take this parent null and I drag it in and I place it into the scene object of the scene render pass, then I get both the 3D text objects because they are children of this null object here. So hopefully you're starting to see how it works. You have these different objects and you're defining them as parameters or as things to be consumed by the scene render pass, and that gets rendered into the screen output. So that screen output is the ultimate result of any render passes that are coming into it. So any object that you're defining, any visual shader that you're applying, ultimately is coming through and out to that screen output. And here we've got the camera texture forming the background. Now I want to point out this part here, which is the default color. So a lot of times when you're doing scene render passes or even shader render passes, you're going to want to click on this default color and you're going to want to take the opacity value and turn it all the way down. And you'll see why we want to do that, because we're going to start to use another new feature later that will utilize that. So that's one thing you want to notice. You've also got different color channels here. So if you wanted to only send the red value of whatever texture is coming in, you could do that by setting the color channel here. And the sizing mode is how that whole render pass is determining what kind of sizing it's going to have as it writes on to the canvas. So if I change that to fixed, you see what you might have seen before if you used model view projections or any kind of projections matrix. What you see is a fixed viewpoint of the camera here, which is unmoving now, and this camera is representing that scene render pass. Because again, if you've got a sizing mode, you could start to think of that as an orientation of looking at that render pass. That's a simplistic way of looking at it. So if I want to encapsulate the camera, then I would go to the sizing mode of camera and use that. Now here's the feature that I think is really interesting. It starts to get very, you start to understand once you start messing with the size parameter. So this is the size of the entire render pass. So if I take that size down, then I see what appears to be a lower quality image, because the number of pixels being used for that render pass is less. So you're gonna essentially see just the amount of the pixels that you're defining here. And what I always say with this is keep the value as low as you can. So you can see at 0.5, I still am very clear in the image, and I don't need the full 100% size to see the quality of pixels that I want for that render pass. And the reason I bring that up is because the more you start to work with these, the more it gets enticing to have tons of them, and you actually run into a memory problem. And that might not be a problem for you writing the filter. You might have a new phone, you know, your resources might be limitless, but you've got to think of other people using your filters, and they might not have the best, newest phone, and their experience is going to be much worse than yours is if you keep the memory of this filter really, really high. And the main way you do that is adding a lot of render passes and having them be really large. So don't do that. Keep the size as low as you can. And there are different techniques in which you could do that. like if you had several render passes. Let's say we move on to shader render pass, which is to consume a shader value. So the difference here is the shader render pass is taking any visual shader information, consuming it as a render pass, basically saving that and saying, I want to write that object to the canvas. And the scene render pass takes into account a scene object and uses all of the children of that object in its account for what it's going to write. So you see the difference here is if I'm just using shader information, like here I'm saying camera texture, then I wouldn't need to go and get a scene render pass because I don't have a particular object that I'm trying to act upon. So that's the difference between those two. And once you start to use both of them, you'll notice that the camera texture could go in as the background of a scene render pass. But if you have a visual shader, say a blur, and that's going into the texture, and then the texture slot result tries to go into the background of that scene render pass, it doesn't work because it actually needs to be computed by the shader render pass before it arrives as the background. And once you've done that, you could get the amount of blur that you want there applied to that camera texture. But you can see here, when it's applied to that camera texture, you're not quite seeing it. You're not quite seeing what you want to see. And the reason for that is because you need to go in and you need to define your materials as well. So here, if I go in and I say, oh, I see the camera texture needed that result. So I could get it there, or I could go in and I could find the very last thing on that drop-down context menu, which is the shader render pass, and that's this one. And it's always helpful to rename your names here, because then if you're doing this method of doing the drop-down, you could see which ones are which. So if I go and I reload it and I say, aha, blur render pass texture, that's the right one. And I've got the right texture for what I want. And so that's just kind of like an intro to how these two work together. But when it gets really exciting is when you add the third thing. So here you're at the stage of you've got 3D objects and you're wanting to, let's put this here and add the blur as the output. Oop, wait for it. As the output here. And let's delete this input and restart. So here, what you've got is the camera texture coming in, you've got the device, then you've got the blur coming in and blurring on both of them. And then if you look here and you said, hey, I want the user material to have the camera texture, there you go. And now you've got the camera texture and the scene object both have a blur on them because they're being processed through a scene render pass. And that right there is the essential part of having 3D objects in a LUT, or having like a dual tone shader and applying it to both the scene objects and the camera texture. It's all right there. So that's your first step. But I want to introduce a new and final concept, which is the delay frame. So the delay frame takes what we've learned about the scene render pass and it expands upon it by introducing the concept of a delay frame, which is actually a frame buffer object. So a frame buffer object is a way to save one frame and repeat it many times throughout the experience. So you've got a runtime, it's going on, and you take that render pass result, which here, we take this render pass result, we put it into the delay frame, and we say we want to repeat that many, many times. So we're going to find the receiver here. So you can see here the delay frame has a blue color, and then it has that little radio signal, which means it takes a receiver. And then if I add a receiver to the scene, then add the delay frame, I can actually go to the beginning of my scene. And just like before, we're going to need a shader render pass, because we can't just put that into the background, because it needs to be computed by a shader render pass. And we put that in after the shader render pass. And we're not seeing anything yet, because what we need to do one more step, which is define the material that we're using as the result of that delay frame as well. So once I've done that, then what I've got going is the delay frame here is saving one instance of that render pass, outputting it, and then I'm taking that output and actually serving it as the beginning start of that background. So if you imagine that snake eating its tail, it's that same concept of you've got the rendered result, you've got it marching forward in time, then you take that marching forward in time and you say, actually I want to start with that result and feed it in to the scene render pass and save every time that gets written to the frame. I want to show it as a render pass. So here it's showing every frame with a slight difference in timing, because it's taken the time to write that per frame using the shader render pass as the background. So, okay, so there was actually a couple more things I wanted to show you, which we didn't get to, so I'm just going to tack it on to the end here, which is how to use the mix here to actually produce different results. So what I've done is I've got a background material that is now getting the result of the shader render pass, and a user material that's also getting the result. And if I just click in the delay frame, you see I only get the texture here, or the 3D object of the render passes. But if I use the mix node and set a alpha value low enough, I could actually see both of them. I could also use the blend here. So if I blend the delay frame and the camera texture, and I say that blend wants to be additive, you can get some crazy additive because it's adding every single frame. And of course, difference isn't going to work here. Overlay is going to get this burned feeling, and so on and so forth. You've got some really great possibilities, but the last thing I wanted to show you was this screen tap value can be used. And if I click the screen tap, you can see here it's actually affecting how that delay frame is being seen. Yeah, I can make it more dramatic here. Now if I add the delay frame to both here, as I click on the tap, it's actually setting that alpha value to 100%, and thus it's going to erase any of the delay texture per frame instances that I have. So that's a common technique that you use a lot, is using a mix and using either a screen tap or a screen pan here to mess with the alpha values and either produce an effect where it's erasing or changing the coloration, depending on what kind of effect you want here. So if I were to say, okay, I just want this to show, and then as I'm pressing the pan, it's going to stop that drawing from happening. So just another technique, and I'll go into that more depth in the future, but I thought, hey, I should tack that on to the end of this because that's actually really interesting. And of course, if you want that 3D text in there, you could add it as the scene object. Both text gets the scene object. Then I'm writing the scene object. And that looks really cool because it looks like I'm just painting. So as I click down on the pan, it sends that alpha value to 100%. Then these two mix together and ultimately write this scene object onto the render pass that then gets transferred to that screen output. Pretty cool, huh? I thought so. So those are some pretty lofty concepts, I know, but as you start to mess around with them, you'll be able to see there's a ton more that could be done with these simple render pass objects. So I hope that that is informative, and if you have any questions, you could go ahead and ask. Of course, I have a Patreon that you could subscribe to. You don't have to. You could just contact me, and good luck. And I'll be making more of these specifically about render pass because I'm so excited about it as time goes on to cover different topics. So thank you and good night.